Hi guys, so let's discuss the concept of mole. The mole is a unit of measurement used in chemistry to quantify the amount of substance. And it was accepted that exactly 12 grams of isotope carbon-12 equal to 1 mole. So it's the same acceptation as a kilogram. So kilogram is 1000 grams. And this unit was just accepted in order just to use it around the world. And the exception was made by mole. So if there 12 gram of isotope carbon-12, it will be 1 mole. And after they decided to count the number of atoms in 12 gram of this isotope, and they found that here 6.02 multiplied 10 to the power 23 atoms. So this is a Avogadro constant. And if you will have 6.02 multiplied 10 to the power of 23 particles can be atoms, can be molecules, can be ions, electrons, it will be considered as a 1 mole. For example, if you have 1 mole of sodium, it means you have Avogadro number of atoms. So you have 6.02 multiplied 10 to the power 23 atoms. And if you have 1 mole of oxygen molecules, it's still particles. So it will be the same number of molecules. So there are three main formulas to calculate the number of the moles. The first and most common formula, it's a mole equal to mass divided by molar mass. Mass here will be in the grams, and you can find it using the balances. Molar mass you can easily find in the periodic table. So the first formula will be applied when you provided or you ask to find the mass. The second formula it's about the number of the particles, so mole equal to number of the particles divided by Avogadro number. Here you need to accept that 1 mole equal to 6.02 multiplied 10 to the power 23 particles. And you will apply this only you have particles in the form of ions, atoms, electrons, molecules, etc. The third formula, mole equal to volume divided by 22.7. It's a gaseous constant. And the volume here will be in decimeter cube. This formula will be only for gases and only at standard temperature and pressure. So you here just need to accept that 1 mole will take 22.7 decimeter cube of volume. Okay, one more time. The first formula you will apply only when you will be provided or you will be asked for mass. The second formula you will apply only you will have the number of the particles or you need to calculate the number of the particles. And the third formula you will apply only for gases at standard temperature and pressure. It's essentially important here, guys, that you understand the logic rather than memorizing formulas. So if you have 1 mole of substance, you have 6.02 multiplied 10 to the power 23 particles. If you have twice more moles, it will be twice more particles. If you have 3 times more moles, so you will have 18.06 multiplied 10 to the power 23 particles. So this is direct proportion. And it can be all. It can be atoms, ions, molecules, electrons, whatever. The same with the third formula. If you have 1 mole of gases at standard temperature and pressure, it will take 22.7 decimeter cube. And if you will have twice more number of the mole at the same condition, it will take twice more space. So it will be 44.5 decimeter cube. And the simple proportion, guys, here, 3 times more at the same condition, 3 times more space required for the gas, 68.1 decimeter cube. Let's train and solve a couple of the questions just to practice. And what is a mole of 11 gram of the carbon dioxide? Here, guys, it's clear that we need to apply the first formula where mole will be equal to mass divided by molar mass, because in the question we are provided with a mass. So first of all, you need to find the molar mass of the carbon dioxide, and you will use periodic table. In the periodic table, you will find that molar mass of the carbon 12 and oxygen 16. However, you have two atoms of oxygen in the formula. That's why you will multiply 16 by 2 and add 12, and overall will be 44 grams per mole. After you will just insert values to the formula, 11 divided by 44, you will get 0.25 mole of carbon dioxide. Okay, so let's solve next question. And here, what is the mass of 2.5 gram of sodium hydroxide? And the formula of the sodium hydroxide provided. So it's obvious that here we'll again use the first formula, because in the equation we have mass. However, we need to transform this formula, and you will find that mass will be equal to mole multiplied by molar mass. First of all, you need to find the molar mass of sodium hydroxide. So from the periodic table, atomic mass of sodium 23 plus atomic mass of oxygen 16 and plus atomic mass of hydrogen 1. Overall, it will be 40 gram per mole. And just insert these values to the formula, you will get answer. 2.5 mole multiplied by 40 gram per mole. We can cancel unit here, and you will get 100 gram of sodium hydroxide will be equal to 2.5 mole. That's the answer. Next question. What is the number of moles of 3.01 multiplied 10 to the power 22 atoms of helium? So here you will apply the second formula, mole equal to number of particles divided by Avogadro number. In the equation you are provided with the number of the atoms, so this number of the atom divided by 6.02 multiplied 10 to the power of 23 atoms. You can write here, because particles and atoms here are the same thing, so you can cancel units. And the answer will be 0.05 mole of helium. And the last question for today. What is the number of mole of 112 decimeter cube of chlorine gas at standard temperature and pressure? So it's a hint here that you will use the third formula, because at 0 degree and 1 atmosphere, you will use only third formula. So mole will be equal to volume divided by 22.7. Volume you will just insert from the equation. So 112 divided by 22.7, it's a gas constant, will be equal to 4.93 moles of chlorine gas. So this is a huge volume of chlorine gas will be only 4.93 mole.